guys. Okay, so now we are going to look at the Gay-Lussac law. So here is the setup. You have a gas that is enclosed inside a sealed container, so the volume remains constant. On top of these containers, there is a regulator which tells you how much of the pressure is inside the container. Okay, now Gay-Lussac, he studied the behavior of gases with respect to pressure and temperature, keeping the volume constant. So now we are going to enclose this container, which is holding our gas, in different, baths. Now there's a heating bath, there's a cooling bath, and you can just leave it, at room temperature. So heating baths can go to a very high temperature, and the cooling bath, similarly, you can bring the temperature down to 0 degrees Celsius and even lower than that. Okay, so depending, what temperatures and the range of the temperatures we are testing, we can use these baths. So anyways, our initial condition is where the temperature is at the room temperature of the gas, which is 25 degrees Celsius. So it is just ordinary water at room temperature. The pressure reading in the regulator is 120 atmosphere. Okay, so we note this down, these are initial conditions. Now we're trying to find out what is going to be the next pressure if you take this container, you put it in a hot boiling liquid, or which has a very high boiling point, and in this case, for example, oil, and the temperature inside the gas reaches to 402 degrees Celsius. So we need to find out what is the pressure at that time. Okay, so we write down all the things that are given to us, and here we are given the pressure, which is the initial pressure. The initial pressure is 120 atmosphere, and we are given the final, the initial temperature, which is going to be the 25 degrees Celsius. And just always make sure that you convert the degrees Celsius to Kelvin. Okay, always convert. So degrees Celsius to Kelvin is 25 degrees Celsius plus 273, and that gives you 298 K. Okay, next is our next pressure, P2. This is the one that we have to find in atmosphere, and let's convert the T2 value, which is 402 degrees Celsius, to Kelvin. So by adding 273, and this comes out to be 675 Kelvin. Okay, so we have the two values of temperatures. We know one value of pressure. We can find the next one. And how do we do that? Always write down the formula. So the formula here is P1 over T1 is equal to P2 over T2. The entity that we need to find is P2. Okay, so we need to get rid of T2. T2 is a known value. P2 is unknown value. Okay, so you are going to multiply this side by T2. So this way, this side you multiply by T2, and this side also on the left-hand side you multiply by T2. So this cancels out this setup cancels out the T2 from the right-hand side. And now we have the T2 on the left-hand side, okay? So now we can just rearrange this a little bit. So we have P2 is equal to P1 over T1 times T2, okay? Or T2 over T1 times P1, that's fine. Okay, and now just plug in the numbers. So P2 is equal to, P1 is 120 atmosphere times T2 is 675 K, and that's divided by 298 K. Okay, so this cancels out the value for the Kelvin, the units of Kelvin, and we are just left with the units of ATM. So when you multiply this whole thing, it comes out to be 270 ATM. That is the pressure. Now you can see also that 270 atmosphere. So if you put this 270 atmosphere, okay, so 270 atmosphere, the temperature has also increased. And when you bring the temperature down, the pressure also comes down. So when the temperature increases, pressure increases. When the temperature goes down, the pressure goes down. So this is another way you can also look at the correctness of your answers. Okay, so I hope that was easy, and thank you for watching. Bye-bye.